Morning. So, I'm not here today. My son got sent home sick, and so I've got to be there. Pretend I'm in the shirt and tie. I know it may seem a little bit weird, but let's move on for what I've got for you today, which should keep you busy for the double bell. If you find yourself with extra time, please feel free to finish up any missing labs. Make sure that other things are done. Check the almost there pile over at the turn in, just in case there's something there that maybe you didn't realize has been waiting for you. But for today, let us move on. So, yesterday, we were working on the restriction enzyme stuff. Hopefully, you remember we were doing the thing where we were cutting between the CCs and the CGs, or GGs and CCs. Oh, it's early. And so that was creating our fragments. And then we were using these fragments in order to create that banding pattern that we saw across most of the gel electrophoresis that works so well for us to determine what is related to what. Well, today you're going to be continuing this process, but on something a little different. So it's going to look more at your analysis and less at your ability to cut. So this was revealed. Today, you're going to be working on this genetic profiling lab. It is up here, up front, with a post-it note on it that says Bell2/3 handout. So make sure that everybody gets it. Now, for this, we're going to start off doing something that we have done many times before, but I want to point out one particular bit of it. Come on. There we go. And that being this part right here. Let me zoom in. All right. The restriction enzyme that is being used cuts at this sequence at GAATTC, those 6 letters in that order. It will cut just after the G. It'll cut right where you see the slash mark right next to it. So it will cut through here. So let me help you out with the first line. And then after that, you guys should be able to work on it. So we're looking for GAATTC. Here is a GAATTC. So I'll cut right after the G. Here is a GAATTC. So I'll cut right after the G. Nope, that's not it. Here's GAATTC. So I'll cut right after the G. Here is a GAATTC. Hopefully by now, all of you get the idea. And then there's one more right here at the end. Now, just like last time, you then want to go back, count out the number of letters on each one in order to get your fragment size. So 1, 2, 3, 4, 5, 6, 7, 8. And then 3, 6, 8. 3, 6, 9, 12, 14. You guys get the idea. You'll do that for each one of these 3 suspects. Then you're going to create their banding pattern down here. Now, we already know suspect 1 has a band at 8 and a band at 14. So suspect 1, here's 8. We would come up and put in that band. It also has one at 14, so we would put in that band. And that's the idea. Finish up number 1, do number 2, number 3. All right, so moving on. Identify who the most likely suspected killer is and explain why. Don't just say it's suspect 2. Say it's suspect 2 because they share 28, 20, and 16. Right? Something like that. Then you're going to go onto the back page, and on the back page, you are mostly analyzing these. So the mare got out. She disappeared. When they got her back 9 months later, she gave birth to this foal, but they don't know who the dad is. Now, two of the possible dads, KD and TC, are both like big horse race winners. If the foal has their DNA, then this is a very valuable animal. Bud is a draft horse. If the foal has its DNA, well, that's not that's not good. That's not what they want. That's not helpful. So, what you're going to do is you're going to go through, you're going to compare and try to identify who the genetic father is. You're going to see this area on the side that says analysis, fragment 8, ignore this, right? That's not going to be important. We're just going to be looking for this part. Then you're going to come down here. Now, in this case, they treated the DNA with a different restriction enzyme. It cut the fragments at different places. So now we have fragments of different sizes. We still want to compare them and see, is one of them the genetic father, and is it the same one? They give you the numbers. So now it's your job to fill it out. So, for instance, the mare has one band at 8. So we would do her band at 8. Then she has one at 12, at 14, and 16. And then, so I did all 4 of those. So now you're just going to do the same thing for each and come to the conclusion. Does it mean the same thing? The last question at the bottom of the page, make sure that you read it. Make sure that you guys give me your best explanation for why this can still occur, even though somebody makes this argument. Now, once you're done with this, let me introduce you to your next lab. I can hear the groans. All right, this is a police report regarding theft from a museum, I believe. Yes, from the City Museum, the crown jewels were stolen. We have 4 different suspects. Now, you can read through this, you can read through how things happened and whatever, but ultimately what we're going to be looking at is this. Our restriction enzyme, in this case, is going to cut between the CCGG. Those 4 letters in that order, CCGG, must be those 4. It's going to cut between the C and the G in the middle. So you can see the examples here. They show you how it makes fragments. And then here is the electrophoresis where you're going to draw in the little banding for the crime scene and suspects 1 through 4. Down on the next page are all of the different DNA strips. Now, once again, I suggest work with your group. If each person works on one of these and gets that done, then everybody can get that information easier. Remember, you are cutting between CC GG. And then at the end, name the members of your team, name the person whose DNA was found at the crime scene. This lab, the crown jewels one, should be real familiar by now. We've done it like 4 times. Will be up front with a post-it note on it saying Bell2 Lab 2. So I hope that helps. With 2 bells, you guys should have plenty of time in order to take care of both of these. Neither of them are going to be super long. If you find yourselves with more time, most of you still have some work that you can make up and finish. So I suggest that you do that. And otherwise, I should be back Thursday. I hope so. And so have a great day. Enjoy, and I'll see you soon.